Welcome to this tutorial on inverse trigonometric functions in NumPy. Today, we'll explore the arcsin function, which allows us to calculate inverse sine values. The arcsin function is essential for finding angles when you know the sine value, making it incredibly useful in mathematical computations and scientific applications. The arcsine, or inverse sine function, performs the reverse operation of the sine function. When you have sine of theta equals x, the arcsine function helps you find the original angle theta. In other words, if you know that the sine of some angle gives you a specific value, arcsin tells you what that angle is. This relationship is fundamental in trigonometry and allows us to work backwards from sine values to angles. It's important to understand the domain and range of the arcsin function. The domain, which represents valid input values, is restricted to the interval from -1 to +1. This is because sine values can only fall within this range. The range, which represents the output angles, spans from -π/2 to +π/2 radians. These output angles are always returned in radians, covering angles from -90 degrees to +90 degrees. Using the arcsin function in NumPy is straightforward. First, you import NumPy as np. Then, you call the function using np.arcsin, passing your input value x as an argument. The function returns the angle in radians whose sine equals x. This simple syntax makes it easy to incorporate inverse sine calculations into your Python programs. Let's look at a practical example with a single value. We import NumPy as np, then call np.arcsin with 0.5 as the input. The result is stored in the variable angle, and when we print it, we get approximately 0.5236 radians. This value represents the angle whose sine is 0.5. If you convert this to degrees, you'll find it equals 30 degrees, which makes sense because sine of 30 degrees is indeed 0.5. The arcsin function also works seamlessly with NumPy arrays, allowing you to calculate inverse sine for multiple values at once. Here, we create an array containing 0, 0.5, 1, -0.5, and -1. We then pass this entire array to np.arcsin. The function processes each element and returns an array of corresponding angles: 0, 0.524, 1.571, -0.524, and -1.571 radians. This vectorized operation is much more efficient than calculating each value individually. While arcsin returns angles in radians by default, you can easily convert them to degrees using NumPy's degrees function. First, calculate the angle in radians using np.arcsin of 0.5. Then, convert this result to degrees by calling np.degrees on the angle variable. When you print the result, you get exactly 30.0 degrees. This conversion is helpful when you need to work with degrees instead of radians, which is common in many practical applications. Let's review the essential points about the arcsin function. First, your input values must always be between -1 and +1. Second, the function returns angles in radians, not degrees. Third, arcsin works with both single values and entire arrays, making it versatile for different use cases. Finally, be aware that if you pass values outside the valid range, the function will return none, which stands for not a number, indicating an invalid result. Keep these points in mind to use arcsin effectively in your projects.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.